Self-organization means organization without the intervention of external agencies. Obviously, it is a challenge to the first law of Newton's first law of motion. There, first law says an external force should be applied to change the state of rest or uniform motion in a straight line. Self-organization envisages autonomy, like Maharaj called it, autonomy for a physical system. There are only physical systems in the world, chemical, biological, whatever, all are physical. So we will adopt that attitude. Whatever is available for observation and for the conduct of experiments is considered physical. That is what we mean by physical. It is not only the domain of physics, but everything that comes in that category, in that domain of physical objects. They need not be macroscopic. They can be microscopic or submicroscopic. They can be particles, they can be fields. We don't know about those things. We can only speculate. We can write equations. We can try to solve them and look for evidence either in favor or to the contrary. So this is actually how science develops, and physics is no exception. I already mentioned in my talk earlier about the inroads that physics makes into other subjects, other disciplines. Physics has ceased to be a self-disciplinary subject or a self-contained subject. It collaborates, it interacts with other disciplines. I have selected two of them, chemistry and biology, for reference in my talk. I am given only 25 minutes to present my material, even though I may need 2 or 3 hours to make things clear to my satisfaction. So most of the things I will simply pass by after showing the slides. The topic of self-organization is actually suited for the study of biology. We should start with biology and compare to physics. But as I mentioned, I am not going to do that adventure for want of time. You can start at the level of protoplasm, cell and so on, and come to the level of non-animate things. That is supposed to be the conventional or traditional domain of physics. But I will follow that traditional route. Start from physics and go to chemistry and biology. You can start the pendulum at any stage of the motion, leave it oscillating. Then you have to apply external force to stop it. You can start at a different point and so on. You allow the pendulum to execute oscillations on its own. The theory says that it will go on doing that for how long? For infinite time. It won't stop on its own. The air currents plus the friction at the support are responsible for the stoppage of motion of the pendulum. Otherwise it will go on indefinitely in consonance with the Newton's first law of motion. It will go on. There is a direction of time. We have been using the clock and the pendulum to measure time, but actually the simple pendulum left to itself will not tell you the time. There is no beginning, there is no end. There is no in between. There is only between two extreme points. If there were only a beginning and an end, you could say the pendulum has started here and is going to stop there and so on. Such phrases are become meaningless once you ignore air currents and friction. In other words, the simple pendulum is an example of what we call reversible process. A reversible process can be reversed. The beginning and end can be reversed. End can be the beginning can be the end. No distinction. You might think that I am talking nonsense or speculative literature, poetry or fiction. No. Reversible processes. If there were no air currents or other forces, then Newton's first law would have been enough. There won't be Newton to discover such a law because he should be born and brought up to the level of discovering that law. Such a thing won't happen because the status quo will continue. The world would not have gone through evolution. Nothing would have changed. There would not have been Big Bang, formation of galaxies and so on. So these are all episodes of universal, colossal importance. Such things would not have happened. Time would have remained stationary. So, reversible processes by themselves do not teach us anything. We need irreversible processes. The world exists because of irreversibility. Now we are reminded of the laws of thermodynamics. First, the zeroth law is never stated in an elementary course, but we should accommodate it also. What does the zeroth law say? The zeroth law says that there is such a thing called temperature. The existence of temperature is an assumption. We are not able to define it. The zeroth, the so-called zeroth law defines it. We know what it is because we play with it. We know how to connect it with other things, but we are not going to define it. As centigrade, Celsius, Kelvin, all those things are secondary. They are not important. Conceptually, the zeroth law contains the definition of temperature. That's all. What? How you define? I don't know. We know how to use that concept. That first law. What does the first law say? It is about the constancy or conservation of energy. Energy may be transformed from one form to another and so on, but the total will be constant. When relativity comes, if you inject relativity, then conservation of energy momentum. These laws apart, now we come to the second law, the all-powerful law. The second law, I am not going to introduce the official version of second law due to Prof and Kelvin and so on. But we need only one concept, that is the concept of entropy. Entropy is a measure of disorder. Because the second law says that entropy measures disorder, it increases to a maximum when a system reaches thermodynamic equilibrium. So we need to know what thermodynamic equilibrium is. Thermodynamic equilibrium is based on three concepts, three notions. First is mechanical equilibrium. The system should be mechanically in mechanical equilibrium. Then thermal equilibrium. Thermal equilibrium means constancy of temperature. And thirdly, chemical equilibrium. Chemical equilibrium means there should not be any chemical reactions. Everything should come to a stop. So this is what is meant by thermodynamic equilibrium. An isolated system will come to thermodynamic equilibrium if it is left to itself. It should be isolated from nature. So this is a fictitious situation. But we know thermodynamics is usually considered something outside the domain of physics, even though physicists claim that thermodynamics is a part of physics. Its applications are historically in engineering and chemistry. In the last century, that is 20th century, around the middle of the century, a Belgian theoretical physicist, Ilya Prigozhin, asked the question. The second law of thermodynamics says that entropy increases in an isolated system. Considering the universe as an isolated system, the entropy will come to a maximum disorder. How do we understand disorder? Disorder means disorganization. Disorder, that is what we call disorder. Organization means order. So disorder and disorganization are synonymous. The second law says that we are heading towards maximum disorder because the universe left to itself, we assume that it is alone in itself, so it has to come to a maximum disordered state, and that will be the state of thermodynamic equilibrium. Simple applications of this idea include the process we call death. We know that we are not in equilibrium with the nature, with the surroundings. The moment you come to equilibrium, you are dead. So that is the best example of thermodynamic equilibrium. It won't be thermodynamic equilibrium because chemical reactions, decomposition of the corpse will proceed on its own. Therefore, it won't be thermodynamic equilibrium, it will be thermal equilibrium because the temperature of the corpse, the dead body will be the same as that of the surroundings. So we have covered basic time and irreversibility are connected. If there were no irreversible things, there would not have been the concept of time, beginning and end. There would be only between, and we may simply say that between minus infinity and plus infinity. These are imaginary points. Ilya Prigozhin wanted to extend thermodynamics, particularly the second law, to biology. The biosphere, the life on earth, as we know. We know that life means organization. Whatever you may say, that most people believe that there is an agency called God which creates life. Physicists would say it is energy. My God is energy. It's not a person. Even in physics, we cannot pinpoint energy. Energy can change from one form to another. God can appear in different forms. Or different religions worship God in different ways. Advaita is the only true theory of nature. It is not applicable to speculation, but it is physics, real physics. It's energy. Everything is energy. Plus, there is a proviso. There is no determinism. There is only chance. So, if you say that God is deterministic, God has his own plans. Even the use of the pronoun his is controversial. How do you know that God is male or God is female? This distinction is irrelevant. Male and female sexes are there for reproduction. God doesn't want another God to come from him, from God. So don't use any pronouns to refer to God. God is energy. If you want a pronoun, then it is the appropriate pronoun to refer to God. God has no plans. God or energy acts in accordance with laws of chance. So this is the basis of today's discussion. I will go to the next slide. In the meantime, this is an example of an irreversible process. A saucer falling from the table. Here in picture 1, a saucer is kept on the table. It slips to the floor. It falls. It breaks into so many pieces. It is an irreversible process, I say. Why? Because the broken pieces by themselves will not go back and reproduce the original configuration. The chances are infinitely small. So, this is how chance arises. But the forward process, the chance for breaking, falling down and breaking is much more than the chance for reverse process. So we need the concept of chance, or the concept of chance arises spontaneously. We are forced into it. We don't say that there is absolutely no chance of the reverse process. There may be a minute chance. Compared to the forward process, namely falling down from the table and breaking into pieces, the other probability is nothing. This is a state of many libraries in our institutions and in certain homes, including mine. The books get mixed up. See, you may identify one arrangement and say that the books are well arranged according to name, album, author, subject and so on. But if you are a real user, you will start jumbling the books. So, the books, the arrangement is altered on its own. As a gas diffusion, such a thing may result in accident, it may even lead to death. So you are leaving a gas stove on, and gas is leaking, the gas molecules diffuse through air. You cannot bring them, you cannot imagine all of them coming back to the gas cylinder and behaving well. So because it is an irreversible process. Child, fetus. We have all passed through this stage. This is an example of self-organization. The child, the fetus, gets organized by itself. The growth happens spontaneously because all the conditions are favorable. What are the conditions for self-organization? There should not be isolation from the surroundings. The system should be open. There should be non-linearity. A linear process cannot produce self-organization. Well, I am cutting short my talk. So certain ideas I am giving less importance than I had planned to. So non-linearity, I hope you know what non-linearity is. Linearity means proportion, straight line, linear. Non-linearity is curves. The variation will be curvilinear. The child is nourished by, the fetus gets nourishment through its mother. Nutrients are passed into the fetus. Then energy and matter should be exchanged. Entropy should be removed. Disorder should be removed. In self-organization, entropy gets removed from a region. Energy and matter are pumped in. They are dissipated, energy and matter are dissipated, or we may say that energy is dissipated, more energy should be pumped in. So that is what is happening in the development of the child. It gets nourishment from the mother, whatever the mother eats, a part of it is given to the child hibernating in the womb. Then energy, gets energy in that process because the digestion, those processes take place, or there is a blood brings in oxygen, energy is brought in, waste products are also removed. So these are essential for self-organization. Self-organization can happen even in equilibrium conditions, but they are not so spectacular. Here, I have shown what happens in paramagnetism getting converted into ferromagnetism. In paramagnetism, the molecular magnets are distributed in random order. At the transition point, Curie, what we call Curie temperature, the molecular magnets are all aligned. This is a process that takes place in equilibrium conditions. Can come. But the Curie temperature is a constant temperature. That is the point. Because of that, it is considered a process which can take place in equilibrium. Crystal growth. You can grow crystals in the lab under steady conditions. So it is also an equilibrium thing. But non-linear and non-equilibrium conditions are essential for self-organization, as in the case of the child in the mother's womb. So a laser. So you might have already noticed that non-trivial self-organization requires coherence. Or in other words, coherent activity when so many subsystems making up a system collaborate or cooperate or unite in a process, we say that there is coherence. Energy, usually in the ordinary case, atoms prefer to exist in the ground state. If they are excited, they immediately try to come down to the ground state. But if you maintain them in that excited state and see that all of them discharge or get rid of their excess energy at the same time, you get laser action. So we say that energy is pumped. Professor V.P. Namburi, the authority in laser physics, is here. I am not going into the details of this, but this is a process of self-organization. Here, atoms in the excited level self-organized. They decide to unite and get discharged, leave the excess energy at the same time, coherently. You know that coherence cannot last for indefinite time. There is a coherence time. Coherence can exist only in a finite region of space and so on. These are all well-known concepts: coherence time, coherence length, and so on. But coherence is the self-organization aspect. It is spontaneous. It is not something which is covered by Newton's laws of motion. It happens spontaneously. This is a standard example of self-organization. In a flask, you are boiling water. There is a temperature gradient between the top layer and the bottom layer. Top is at a lower temperature than the bottom. We say that there is a temperature gradient between the bottom and the top. Initially, nothing very spectacular happens, but there is what is called boiling. It is a phase transition. It's a cooperative process in which all these molecules collaborate. Before boiling takes place, and what we call convection currents arise. This convection means bodily movement of water from one place to another. Water from bottom rises to the top. We are all familiar with the process. As we heat water, hotter parts of water rise to the top and the colder parts descend. This is what we call convective motion. Just before that happens, certain geometrical patterns arise spontaneously. It may not be visible to the naked eye, some coloring or some using cork powder, etc. You can actually observe it. In the case of water, it has been reported that hexagonal cells, that is the shape of the pattern, arise, and that is the penultimate stage. Before boiling, just before convection starts occurring globally, these geometrical patterns arise. That is an example of self-organization in fluid dynamics. There are differential equations for all these things. There is what is called Belousov-Zhabotinsky reaction. Belousov-Zhabotinsky reaction. Those who know chemistry may know about it. It is a special type of chemical reaction. Belousov and Zhabotinsky were the people who studied it. Something very spectacular happens in it. It is, in chemical terms, it is simply an oxidation process. Malonic acid is oxidized by potassium bromate in a sulfuric acid medium. That is an experiment. Malonic acid is an acid, certain acid. It is oxidized. That means it gives away electrons oxidized by potassium chromate. Then very funny structures arise. You get, if you increase the speed of pumping, you have to use catalysts also. Cerium sulfate is the catalyst. Cerium sulfate should be pumped into I am not going to write anything. I have already mentioned the names of the chemists who discovered it. Belousov and Shabotinsky. You can refer to Google. You type Belousov, the spelling need not be standard. Belousov, Shabotinsky, Z starts with ZH, Shabotinsky reaction. You will get a number of references. One of the outstanding things which you will be able to see is a live picture in which there will be flickering. The medium will be red for some time, then blue, red and blue. So this is not orderly, it is chaotic, becomes chaotic. So it is self-organization, pattern formation, and this you can observe in your phone. I observed in my phone. You open the Google and type this, go through whatever, all the material given there. You will be impressed by the variety of processes or products that you can observe in self-organization processes. Biology, actually I wanted to spend more time on this. Brain, how self-organization takes place. If you are listening to somebody, to me right now, you are listening to words, a certain portion in the brain becomes active. Using the language of self-organization, it means the neurons there organize themselves in recognizing the words. Then thinking of words, you will see still different regions of the brain becoming active. The brain becoming active means neurons, different classes of neurons. The details are very, very interesting. Actually, I could have given a talk on that, but unfortunately, I don't have time. How neurons get involved in this. The neuron, I have written a poem on irreversible things, processes. The title of the poem is Irreversibles. It is there in the book, Into a Cul-de-sac. It was published last year. It's a book of poems, more than 50 poems. For a background of the theory leading to self-organization, you can refer to this book written in Malayalam long ago in late 1990s. Unfortunately, copies of this book, which has gone through 2 or 3 editions, are not available. So recently, DC Books asked me to sign an agreement if I want this book to be reprinted. So they are going to reprint it and put up for distribution soon. You won't get any idea about self-organization from this book, but the background, non-linearity, chaos, all those things are discussed in that book. I have started writing another book on self-organization. I can only promise to bring it out maybe next year if I continue to be alive.